Have you ever wondered why we haven't just handed over the keys to our greatest cosmic ambitions to artificial intelligence? We live in an age where AI can compose music, defeat grandmasters at chess, and even pilot our cars through busy city streets. It seems logical, almost inevitable, that the next step would be to let these powerful digital minds design and build our most complex machines. So, why isn't an AI already constructing the next generation marvel, Starship 37, destined for the red sands of Mars? The answer, it turns out, is as vast and complex as the universe itself. It reveals a fundamental truth about progress and the irreplaceable role of human consciousness in our quest to explore the cosmos. Let's get one thing straight, right here and now. The popular idea that AI is a magical, all-knowing entity ready to solve every problem is a myth we need to bust. We see it in movies and read it in headlines. This notion of a super intelligence that can outthink, outcreate, and outmaneuver human ingenuity at every turn. But the reality is far more nuanced. AI, in its current form, is a phenomenally powerful tool, but it is just that. A tool. It operates based on the data we provide and the algorithms we design. It doesn't possess genuine understanding, intuition, or the kind of spontaneous creativity that fuels true innovation. It's a brilliant student, but a student nonetheless. When we talk about building something as revolutionary as Starship 37, we are not just assembling parts according to a pre-existing blueprint. We are venturing into the unknown. We are solving problems that have never been solved before. Think about the challenges: developing new alloys that can withstand the extreme temperatures of atmospheric re-entry, designing life support systems for a multi-year journey to another planet, or figuring out how to refuel a rocket in orbit. These are not tasks that can be completed by simply crunching existing data. They require a leap of imagination, a spark of insight that goes beyond pattern recognition. So, while an AI can analyze millions of simulations to optimize a fuel injector's performance, it cannot sit down with a blank sheet of paper and invent the fuel injector in the first place. It lacks the context, the lived experience, and the fundamental curiosity that drives a human engineer to ask, what if we tried this completely different approach? AI is an incredible accelerator, a force multiplier for human intellect. It can take our ideas and test them at lightning speed. But the ideas, the dreams, the audacious goals, those still have to come from us. That is the cosmic truth of our current technological era. To understand why AI can't build Starship 37 alone, we need to appreciate what it does exceptionally well. Modern AI excels at optimization and analysis within well-defined parameters. For example, you can feed an AI the design of a rocket nozzle and ask it to make it 5% more efficient. It will run millions of virtual tests, minutely adjusting the shape, material thickness, and flow dynamics in ways a human team might never consider. It can sift through mountains of telemetry data from a test flight and pinpoint a subtle vibration that preceded an engine anomaly, a needle in a cosmic haystack. These are not small feats, they are transformative. However, the AI's strength is also its greatest weakness. It is fundamentally constrained by the data it has been trained on. Its knowledge is a reflection of past successes and failures. When faced with a truly novel problem, a situation for which no data exists, an AI is often stumped. Imagine the early days of rocketry. The challenge wasn't to optimize a liquid-fueled engine, it was to conceive of one in the first place, moving beyond solid-fuel rockets. An AI trained only on data from fireworks and cannons would never have independently invented the complex turbopumps and combustion chambers of a modern rocket engine. It lacks the ability to make an intuitive leap into a completely new paradigm. This limitation becomes critical when we consider the iterative and often messy process of building a spacecraft like Starship. The development journey is not a straight line. It is filled with unexpected failures, surprising discoveries, and moments where the entire plan has to be rethought. Remember the early Starship prototypes that spectacularly exploded on the test stand? An AI, focused purely on the successful execution of its program test, might classify this as a complete failure. A human engineering team, however, sees it as a rapid, unscheduled disassembly, a valuable, albeit dramatic, learning opportunity. They gather around, analyze the wreckage, and ask the crucial question: what did we learn? This process of learning from failure, of adapting and improvising, requires a type of judgment that AI cannot yet replicate. A human engineer can look at a failed weld and connect it to a seemingly unrelated change in the factory's humidity that day. They use a holistic, contextual understanding of the real world, the messy, unpredictable, physical world where rockets are actually built. The AI operates in a clean, digital space. Humans operate at the chaotic, creative interface between the digital model and the physical reality, and that is where the most important breakthroughs happen. The secret ingredient that AI is missing is genuine, unbridled creativity. This isn't just about artistic expression, it's about the ability to connect disparate concepts in new and useful ways. A human engineer might be inspired by the structure of a bird's bone to design a stronger, yet lighter, support strut for a fuel tank. They might solve a complex fluid dynamics problem by recalling a principle they learned while surfing. This cross-pollination of ideas, drawing from a lifetime of diverse experiences, is a uniquely human cognitive skill. AI, confined to its specialized domain, doesn't go surfing on the weekend. It doesn't get inspired by biology unless we specifically program it to look for those connections. Furthermore, building a machine as complex as Starship 37 is a profoundly collaborative endeavor. It requires hundreds, even thousands of people to work together. It involves communication, negotiation, and shared purpose. Think of a meeting where the propulsion team, the life support team, and the materials science team are all in a room. The propulsion lead might want a bigger engine, but the materials expert knows the current alloy can't handle the heat. The life support engineer needs that space for a water recycler. It is in this dynamic, human-to-human interaction that compromises are made and brilliant, integrated solutions are born. They use empathy, persuasion, and a shared vision to find a path forward. AI cannot replicate this intricate social dance. It can't read the room, sense the hesitation in an engineer's voice, or build the trust necessary for a team to take a huge, collective risk. Human leadership is about inspiring people to do their best work, to push beyond their perceived limits for a common goal. It's about the manager who shields their team from bureaucratic pressure, so they can focus on solving a critical problem. It's about the senior engineer who mentors a junior colleague, passing on not just technical knowledge, but wisdom and a way of thinking. This is the organizational and emotional fabric of great engineering projects. Ultimately, human judgment is indispensable when the stakes are this high. An AI might calculate that a certain risk is statistically acceptable, say a 1 in 100,000 chance of a catastrophic failure. But a human project manager, responsible for the lives of the astronauts on board, might look at that same number and say, that's not good enough. This ethical and moral dimension of decision-making, the ability to weigh quantitative data against qualitative human values, is beyond the scope of any current algorithm. When we are making choices that will define the future of our species in space, we need human wisdom, not just machine intelligence, at the helm. So, what does this all mean for the future of space exploration and projects like Starship 37? It means the future is not about humans versus machines. It is about a powerful partnership, a symbiosis between human ingenuity and artificial intelligence. The most effective path forward is one where we leverage AI as an extraordinary tool to augment our own abilities. We let the AI handle the grueling calculations, the endless simulations, and the meticulous data analysis that it does so well. This frees up human engineers to do what they do best, to dream, to create, to innovate, and to lead. Imagine an engineer working on a new landing leg for Starship. They sketch out a radical new concept inspired by a grasshopper's leg. They then hand this concept over to an AI, instructing it to run 10 million structural and aerodynamic simulations, testing thousands of material combinations and environmental conditions. The AI returns a refined design in a matter of hours, a process that would have taken a human team months. The engineer then uses their experience and intuition to interpret the results, make the final design choices, and oversee the physical manufacturing and testing. This is the model for 21st century engineering. This collaborative model is how we will push the boundaries of what is possible. We, the humans, will continue to be the source of the big questions. We will be the ones who look at the moon and say, let's go there, and then look at Mars and say, let's build a city there. It is our curiosity, our ambition, and our relentless drive to explore that sets the agenda. The AI doesn't dream of going to Mars. It doesn't feel a sense of wonder when it looks at images from the James Webb Space Telescope. That's our job. We provide the why, and in partnership, we and our AI tools figure out the how. Therefore, the construction of Starship 37 and the spacecraft that will follow it will not be the work of AI alone. They will be monuments to human-AI collaboration. They will stand as testaments to our ability to create tools that amplify our intellect and extend our reach. The human touch, our creativity, our collaborative spirit, and our unwavering judgment will remain the most critical component in our journey to the stars. The universe awaits, and it will take all of our uniquely human qualities, working in concert with our most advanced technologies, to answer its call. The future of space exploration is, and will remain, profoundly human.